let's look at another difference quotient problem. So here I have a function 3x squared minus 5x plus 4. So in order to evaluate the difference quotient, I'm going to have to find f of x plus h. That's going to require me to plug in x plus h everywhere I have an x in my original function. And I want to go ahead and simplify this. So I'm going to end up distributing my binomial. I can go ahead and distribute that negative 5x. And finally, I'm going to go ahead and distribute this 3. So f of x plus h in its fully simplified form will be 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4. Now I'm going to plug this into my formula, right? And so when I want a difference quotient, I'm going to take f of x plus h minus f of x all over h. In this case, our numerator will be exactly what we just found. I'll just copy that down. And then from that, we are going to subtract the f of x, which is 3x squared minus 5x plus 4. And all of this will be divided by h. Now we're going to simplify our numerator as best we can. 3x squared minus 3x squared will cancel. Negative 5x minus negative 5x will also cancel. And 4 minus 4 will cancel. That leaves us with a difference quotient, with a difference quotient of 6xh plus 3h minus 5h, all divided by h. Notice that the h exists in all of our terms, so we can divide it out. And our simplified form will be 6x plus 3. This 3h should be squared. So I'll have 3h minus 5. So what that represents, it represents for this given function, the slope between some x value and another x value h units away. Let's check our work to see if this makes sense. Let's say we had two x values. So I chose 2 and 5, and I plugged those values in to find my f of x1 and f of x2. I plugged 2 in to my original formula, and I plugged 5 in, and I got these values. So if I were to find the average rate of change between these 2 points, I would take 54 minus 6 over 5 minus 2, which is going to be 48 divided by 3, or 16. Now our x value here, if we're using the difference quotient, would be 6. And our h value, our x value here would actually be 2. Our h value is the horizontal distance between the two x's. In this case, our h value would be 3. So what I'm doing right now is checking to see, does our difference quotient work? Well, I have an x value. I use my x1. And my h value is the horizontal distance from that x value, to the second x value. So from 2 to 5, there's a difference of 3. So if I were to plug just those x and h values in to my final answer, I would have 6 times 2 plus 3 times 3 minus 5. So I'm going to evaluate this. I'll get 12 plus 9 minus 5. 21 minus 5 is 16. Hopefully that sounds familiar. That is the exact value of the slope between points x1 of 2 and x2 of 5 that we found directly using our average rate of change formula. I could do the very same thing with the simplified form of our difference quotient, plugging in our x and h values.